Module 2 Applied Agroclimatology and Agricultural Planning. 1. Equipment and maintenance of standard meteorological stations. A meteorological station is a facility that collects data about atmospheric conditions to support weather forecasting, climate study, and agricultural decision-making. In agroclimatology, these stations are particularly important because they provide precise, local measurements that guide farming practices. Types of meteorological stations. Synoptic stations collect a full range of weather data, often hourly, for national meteorological networks. Agrometeorological stations focus on climate data relevant to agriculture, including soil temperature and moisture. Automatic weather stations use sensors and data loggers to automatically record and transmit measurements. Key instruments in a standard meteorological station. Thermometers measure air and soil temperature. Hygrometers measure humidity. Rain gauges measure precipitation amounts. Anemometers measure wind speed. Wind vanes indicate wind direction. Barometers measure atmospheric pressure. Sunshine recorders track the number of sunshine hours in a day. Evaporation pans measure evaporation rates. Maintenance practices. A well-maintained station ensures accurate, reliable data. Calibration, regular checks to ensure instruments measure correctly. Cleaning, keeping equipment free from dust, insects, and debris. Proper sighting, the instruments must be placed in locations free from obstructions and at standard heights. Protection from tampering, fencing and signage to prevent damage or interference. Farmers and agricultural planners rely on data from these stations to forecast rainfall, schedule irrigation, monitor crop conditions, and prepare for extreme events. 2. The tropical climate. The tropics lie between the Tropic of Cancer and the Tropic of Capricorn and have distinctive climate characteristics shaped by high solar radiation, proximity to the equator, and unique atmospheric circulation patterns. Main characteristics of tropical climates. High average temperatures year-round, with small seasonal variation. Distinct wet and dry seasons rather than 4 traditional temperate seasons. Intense solar radiation leading to high evapotranspiration rates. Heavy rainfall in some areas, often in the form of thunderstorms. Types of tropical climates. Tropical rainforest, hot and wet all year, with dense vegetation. Tropical monsoon, marked wet and dry seasons influenced by monsoon winds. Tropical savanna, grasslands with scattered trees, seasonal rainfall. Semi-arid tropics, hot but with limited rainfall, prone to drought. Understanding tropical climate patterns is essential for determining suitable crops, planting seasons, and water management strategies. 3. Agriculture and climate interconnections. Agriculture is inherently tied to climate, and every stage of the farming cycle is influenced by climatic factors. Impact on crops. Temperature affects seed germination, growth rates, flowering, and fruiting. For example, maize thrives in warmer temperatures, while potatoes prefer cooler conditions. Rainfall determines the availability of soil moisture for plant growth. Rain-fed agriculture depends entirely on predictable rainfall patterns. Sunlight drives photosynthesis, affecting yield potential. Wind can assist pollination for some crops but may also cause lodging when plants are blown over. Impact on livestock. Heat stress can reduce feed intake, growth, and reproduction in animals. Cold stress increases energy needs for maintaining body temperature. Water availability critical for drinking, cooling, and forage production. Disease patterns. Climate influences the spread of parasites and pathogens. Impact on irrigation. The timing and amount of irrigation must match crop water requirements, which vary with temperature, rainfall, and evapotranspiration rates. In dry periods, irrigation becomes essential to sustain yields, but over-irrigation can cause waterlogging and salinity problems. Impact on pests and diseases. Warm, humid conditions favor many plant pathogens and insect pests. Climate shifts can lead to the migration of pests into new regions. Monitoring weather data can help predict pest outbreaks and guide control measures. 4. Seasonal agricultural planning. Farmers must synchronize their activities with the seasonal patterns of temperature, rainfall, and daylight. In tropical regions, the onset of the rains often signals the start of the planting season. The peak rainy period is crucial for crop growth but may also require pest control. The dry season is ideal for harvesting and for sun-loving crops like groundnuts. Examples of seasonal planning. In a monsoon climate, rice planting starts with the arrival of rains, while wheat is sown in the cooler, drier months. In savanna areas, short-duration crops like cowpeas are planted early in the rainy season to avoid drought at maturity. Agroclimatological data allows for precise crop calendars that guide farmers on what to plant and when, reducing the risks associated with unpredictable weather. 5. Climate adaptation strategies in agriculture. Given climate variability and change, farmers are adopting various strategies to minimize risk. Crop diversification, planting different species to spread risk. Drought-tolerant varieties, choosing crops bred for resilience. Water harvesting, capturing and storing rainwater for dry periods. Agroforestry, integrating trees with crops to provide shade and reduce evapotranspiration. Adjusting planting dates, aligning sowing with favorable climate windows. By understanding agroclimatology, farmers can select strategies that suit their local conditions and available resources. 6. Case study: Climate and maize production in West Africa. Maize is one of the most widely grown crops in tropical Africa, but its yield is highly dependent on rainfall distribution. In the savanna zones, maize performs best when planted at the onset of the rainy season. Early cessation of rains can lead to crop failure if maturity is not reached. Too much rain during flowering can reduce pollination success. Meteorological data from local stations help farmers and extension officers determine optimal planting dates to maximize maize yield. 7. The role of agroclimatology in policy and development. Governments and development agencies use agroclimatological data to plan irrigation schemes, develop early warning systems for droughts and floods, support crop insurance schemes that protect farmers against climate-related losses, guide investments in infrastructure, such as storage facilities, to handle seasonal surpluses and shortages. By integrating climate knowledge into agricultural policy, countries can improve food security and resilience against climate change. 8. Conclusion and integration of knowledge. In this course, we have explored both the theoretical and practical aspect of agroclimatology. From understanding the elements and controls of climate to applying meteorological data in agricultural decision-making, the goal has been to equip you with the skills to link climate science to productive farming. Key takeaways. Climate is a primary driver of agricultural success or failure. Accurate data collection through meteorological stations is vital for planning. Tropical climates present both opportunities and challenges that require careful management. Seasonal agricultural planning, supported by climate data, improves efficiency and reduces risk. By applying the principles learned in both modules, you will be able to assess local climate conditions, predict their effect on crops and livestock, and make informed decisions to enhance productivity and sustainability in agriculture.